It's really a pleasure to talk about this. It's something that's a passion of mine. Okay, and the question here it's how to mix mechanics with biology. Okay, so that's what I am trying to explain today, and to see how we can get better results by having the two concepts in our mind. So the first person who did this, as we have registered, it was on mythology, Pygmalion, who lives in a city that he was not happy enough with the beauty of the ladies that exist in his town. So he decided to make a sculpture of the perfect women. And then he asked to the gods to give him life, and they give it life to him, and he live with her ever happy. Okay, so and when we are talking about these feelings about perfect and mixing mechanics with bio, the first thing that it occurs to us, it's the subperiosteal implants. And in reality, that gives us some nostalgia and that gives us some romantic thoughts about it. So it's coming back. But unfortunately, what I'm going to say today, it's not coming back. Okay? It's like to compare blades with the osseointegrated implants. Okay? So this is the focus that I'm going to try to explain today. Okay? First of all, we need to look at the anatomy of the resorptive mandible or the maxilla, the jaws. When we are on basal bone, there are some things that disappear like keratinized tissue. And another thing is that we are coming to the level of muscles. And all we know that even worse than not having keratinized tissue is to have mobility of the tissue around the implants. And that's one of the main causes of periimplantitis. So with this thought, what we have done is that we have looked for our experiencing on plating, mainly on orthognatics. And we know that on orthognatics, we have places to put our plates. Otherwise, they will expose. And one of the most common exposed, it's the one from the zygoma. It's really exposed during time. And sometimes we have even to remove it. And what have we found it when we remove it? So we start to, the first screws they will lose immediately, of course. And then we found, when we start to open a flap, we start to find some inflammatory tissue. But when we go deeper inside, what we see is that bone is growing over the plates. Okay, everyone that has to remove plates for some reason already assists to this. So there is a line that we have to put our plates to protect from exposure. And this line, it's connected to muscle insertion. Okay, so that's why we have decided to create this concept that what we have to do with the implants on very resorptive jaws, where we cannot place regular implants, okay, this is the main focus of it, okay, it's to have to search for a musculoskeletal integration of the implant, okay. So what we do in reality, we don't do subperiosteal implants. What we do is that we do mid-face fixation, okay? And we are going to look for jaw, and the first article that appears, it's from 1901, okay? 1991, okay? So it's something that every day is done on every places, okay, around the world. I heard that it's calculated about 1,500 a day that it's placed, okay, over the world. So this was defined by René Lefort, okay, and this has to be with the Lefort one fracture. And how do we fix it? Okay, so this has mechanical reasons to do that. So the J or L type of plates, they have a mechanical issue. They are on the pillars of the face, and also they have the straight line along the occlusion force, and then an oblique line or a parallel line for torsion of the maxilla. So I don't know if this is somewhere. Let me put it like here. So in our case, we have tried to look for the main reason for implantology be a success as we have it today. It was what Professor Brandmark has described. And for this description, we have lots of parameters that we have to follow. So like micromotion and the biocompatibility, to have a surgery that it's not very traumatic, not, and a healing period. So this is something that all the Professor Brandmark has brought to us, and it makes us the new era, by using osseointegration. And when we compare subperiosteal versus what we do, okay, we call it Implantize Compact, is that we are not doing a custom case for each case, okay? What we have is that we have a design, okay, with a large threshold, and this threshold allows us to adapt this implant to each anatomy, okay? But it's going to be always the same type of screws, not length, of course, but always 5 on the piriform apophysis, 2 screws that you are going to see on zygoma, and these screws have this special thing, and 2 screws down the zygoma, 1 screw inside. So this will allow us, and this is what we call patient match, okay? This allows us to have something that we can really make analysis of the performance of this type of implants, okay? We cannot compare 2 implants that are designed for 2 different persons and have 2 different concepts. You cannot say bad about subperiosteal if one of the persons do it tripod and another person do it other way, okay? So we need to have a line of design that is have to be always the same to compare cases to other cases, okay? Another thing is that most of the people think, and I will come back later about this, that as thinner as possible, not to have an exposure. Well, we say it as rigid as possible. For us, this is very, very important. And I will come back to this later. So this is the reason that we divide it in 2 frames, okay? So we don't use 1 frame. 1 frame, if you pick up, you can bend it, okay, on the points. And if you can bend it by pressing the extremes of this implant, if you put an occlusion force, it will open, okay? And this is really a big problem. Also, we use multi-unit type abutments, which has an ISO as regular implants, and as I told you, this design threshold. And we have 5 years of performance studies over this because it's always the same, and this allows us to have results, clear to have results and understand the problems, okay? So what is the big concept? So the implant, first of all, we go always basal, okay? This is one of the things. And going basal with special bursts, if we have some type of alveolar process. We reduce it with this special bus with the help of a guide, of course, and we go almost to basal. Okay, this will come to the place where the muscle insertion will occur. So what you have is that you have a flat crest. By having a flat crest, you do not have any chance to have exposure, of course. You can understand that very, very easy, okay? Anyhow, if you have a flat crest, on buccal, you will have movement about your of your tissue, okay? And if you have mobility of the tissue, we know what will occur, okay? You will have inflammation around the implant. But picking up the first concept that I have told you about plates, what happens when a plate exposes, a mid-face plate, you find that there is a inflammatory tissue, but every part of the plate that it's below the muscle insertion, it's covered by bone. Okay, so for that we go here, and also these burrs, they have kind of a chamfer. You do a chamfer when you do bone preparation, and these will take out sharp angles, and because it will give you a better mechanical it will give you a better mechanical performance, okay? Because the force will not have straight parts, and it will not bend so much, okay? Also, the screws that goes inside the zygoma, they are screw locked. That means that they screw on the implant, okay, making it rigid. For us, it's not a big problem for the screws that are perpendicular to the force, because they are inside a cone that is designed on the plate, so there is not micro movement. But these ones that are more or less parallel to the force, they tend to gain a gap. And this is very important. Try to imagine, okay, I put an implant, okay, and it's not really a plate as LaFor1, because on LaFor1 we are going to load the bone. Here we are going to load the plate. So if you are loading a plate and you are just pushing it against bone, what you will have is that you will have remodelation of the bone. And if you have some remodelation of the bone, then you will start to have gaps. And if the screws are only pressure the plate against bone, then they will get a gap, and then they will get micro movements, okay? So, and this is what we want to avoid. We know that for us to have an osseointegrated system, we need to go below 30 microns to have the mineralization of the matrix around the implant. So this is the most basic concept about osseointegration. And if we have something that moves a little bit inside the body, it will never osseointegrate, no? And if you don't move a leg, then all your muscles will start to mineralize, okay? All the tissue that doesn't move, it will start to mineralize. So this is very, very important to understand. And for us, it's always very important. And because we do always FEA, finite element analysis for every cases, okay? We always try to make the simulation and try that the micro movement induced by the occlusal forces be always below 50 micron, okay? This is what is going to change from subperiosteal implants. You know that from subperiosteal implants, you accept that it can move a little bit. You even accept that on zygoma implants, and you let it stay, and you call it that is a success. But anyhow, it's not a success. You cannot compare it, this type of success, only because you cannot take it over. You don't have to take it out, sorry. But it is not the same success as dental implants, okay? For dental implant, if a dental implant have movement, it has to be removed, okay? And the same for us. For us, every implant that moves, it is a problem, and we have to remove it, okay? So as I told you, we do always FEA, and that gives us a lot of experience and a lot of analysis of what we are doing. So we did an experience, and we did FEA for two systems, Norris-Zygoma and our implant. So for Norris-Zygoma, we choose 4 lengths. They have the smaller one, 40, 50, and 57.5, which is the longest that they have. And then we apply occlusal forces, but with one difference. For each one, we have applied it at 30 degrees, 40 degrees, 50 degrees. It will make a lot of difference. You cannot analyze only if you are going to make in one angle, because the anterior, if you are doing a quad zygoma, for example, the anterior zygoma will be on a much open angle than the posterior. So behavior will be different, okay? Also, Norris defines that they have, although they have 12 millimeters of apical part that is prepared, only 7 millimeters engage in bone. So that's what we do. And for us, our implant, it has always 2 connections, so we have to apply the force on the 2 connections. And the force apply, it's the regular thing, it's more or less defined is 200 newtons. So what criteria do we evaluate? We have evaluate displacement. Displacement is micro movement, how much it displaces, okay? Micro movement that is induced, and safety of breaking, okay? From certain point, it has a tendency to break. So this is our simulation, okay? And we have used a 50 degrees. We have done it on 30, 40 and 50 degrees. And this is the result. Let me help you, okay, to tell you what this is. So this is for 30 and the 3 angles, for 40 and the 3 angles, for 50 and the 3 angles, 30, 40, 50. And then we evaluate the minimum safety factor. So we have a large safety factor here, but as we are growing longer, if the length starts to grow and the angle, then the safety starts to decrease, okay? On different way goes the displacement, okay? And the displacement is 240 microns for the smallest one. And if we go to the 57.5 at 50 degrees, we can get 3.6 millimeters of displacement, okay? So this is much more near of subperiosteal implants, because the movement that induces, and that's why we see at the end of some years that that there is a big resorption of the sinus wall, and also it starts to have communications. But with us, what we did is that we applied the constraints. It's the point that we put our screws. We apply the force, so the safety factor is very high, and the displacement, it's 17 microns, okay? 17 microns, it's always what we search. Every time that we have something above 50 microns, we make it thicker, okay, our implant, because what we want is after it's an occlusion force, it is applied, we want that doesn't bend, okay? What we want is that the implant doesn't have micro movements. If it has micro movements, as I showed you before, below 30 microns, then we can achieve osseointegration. Okay? So this is the conclusions. We have displacement from 0.2 millimeters to 3 millimeters 0.6, and of course the value of the safety, it's decreasing. So let me try to guide you on the surgery, okay, for you to see step by step how is it this type of surgery, okay. So this is an implant that is sterilized like a regular implant. It's sterilized by ETO, so you cannot open it before surgery. And what we do is that we do a shoe horse opening of horseshoe, sorry, and just placing like this, making this flap, okay, that we have to see all this part. It's not much different from zygoma or even from superior. So in reality, it's the same approach. But what we have is this. We have this type of guide, okay? This guide, it's important. These slots will guide the drills that make the preparation of the bone. So you need these slots, you need this slot to make this preparation for the implant be on the same place that we have projected, okay? Not only that, but we have here 3 points for the fixation of the guide, but then we have 3 points on each side that we can either make a small drill or paint it, okay. And this way, when you are going to test the implant, you will see if it is on the right place, okay. So these types of drills that are going to be used, they are going to make this chamfer outside. You know that buckle, it's always the problem at where we have exposures of the implant. So we always need to make and also because we do our connections, we always put it on a palatal approach, okay, to be inside a bone envelope, okay, and this bone envelope gives you some, it gives you attachment to the gum around the implant, and it reduces a lot the movement, the mobility of the tissue. So it is placed, okay, and after placed, we have to do the bone preparations. And we have here what drills we should use, okay, by color. In this case, it was only one drill. It's the green drill, sorry, the green burr. And this is the implant. The implant comes with these small guides for preparation of the zygoma. These guides, they are screwed inside the implant because, as I told you, here, after we make the preparation of the zygoma, we will remove the guides and the screw will engage on the implant, okay? So the screw will be fixed to the implant, okay? It's like screw lock the system plates. And you can see it here. Here, these ones, they are inside this part that has the threads, okay? These are 2.7 screws, okay? And you see, you probably will say this thing, this is bulky, okay? Of course it is bulky. What we need is to have and to achieve a great performance, a great mechanical performance, okay? I don't care if it is bulky. What I want is not to have micro movements. Only by not having micro movements, and we know that the different from the past, it is that the osseointegrated system make the implant to be a part of bone. I need that bone grows around the plate, and if it grows around the plate, every time that I have some kind of inflammation, I have a tissue that are able to respond to give an answer to the aggression of bacteria. Okay, only and that's the main problem. We always discussing about zygoma making starting making approaches from the outside of sinus because it induces sinusitis. The main problem is to have problems with sealing. Okay, if you have micro movements, tissue will not seal around the connections. And for sealing, we also do this constriction. This constriction, we know nowadays that this constriction forces to have circular fibers that will protect the infiltration of bacteria. Okay. And as you can see, everything is a little bit in palatal approach. Even our plates, they try to get out of the points that are more out on buccal, like pyramidal apophysis from the sinus or any part that is a little bit out. So we try to put it inside a little bit bone envelopes. And it from one side to the other side. And what I want to tell is design is always the same. What you are seeing here, it's a small modification of Lefort-1 fixation. So it's not kind of a sensation. It's not kind of a nostalgic, romantic thoughts about superiosteal. No, what we do is that we use science to design the solution. And let me try to approach now the mandible. On the mandible, what we use is that it was in 1978 that Professor Ciampi has defined the Ciampi lines, which are the lines of less bending of the mandible, which is the anterior border of the ramus. It is the external oblique line and the point below the basal point of the mentum. Sorry, and this is the point where you have less flexion of the mandible. We know that the mandible has two types of flexion. This was described on the older implants, that the problem was the flexion of the mandible, and that induced some type of bone resorption. So what we do is that we just use the Ciampi lines, and when you are going to, and this was designed by Professor Ciampi in 1978. So, and when you see, this is the first drawing that he did on his first paper. Okay, what you are going to see over this new type of implants is that you are going to find this same design. Okay, and this design is what works for every day on every hospital. Every time that someone arrives with a fracture, it's these points that we use to put the plates, because we know that after this paper we did not have the need to use bicortical screws with the plates on the border. Okay, so we can reduce fractures by using only these lines and with monocortical 2.0 screws. So again, as you see, what you are going to see, it's what Professor Ciampi has shown us. There is a line where the mandible has less flexion. And why this is important? Because imagine what it passes if the flexion of the mandible starts to this implant, which is not flexible. What will occur is that the screws will be pulled out of bone. Okay, if you have flexion of the mandible and not of the implant. So that's why we need to use these plates are called semi-rigid plates because of that. The mandible have so less flexion on these points that it's not enough to take out the screws from the plate. When we see those large plates here in the border of the mandible, what we find several times is that there are lots of screws that come out of the plate of the bone because of this flexion. So the same concept that we use the special burrs There is a special burr for the posterior region. We try to make a chamfer on the external oblique line, on the internal oblique line, and we use muscles to protect our fixation. We accept that you are going to have inflammation. It's impossible not to have inflammation if you have mobility of the tissue. What I want is not to compromise my fixations. And that's what I'm going to try to show you here. You can see mentalis, you can see buccinator, you can see masseter, you can see milioideo. And what I try to do is to force all these muscles to go above the plates. And by going above the plates, it's the same thing that I have talked on the first part. It's saying that I can have inflammation of the plate, but when I go deeper, what I found, the muscles will give me a protection that on standard implants are given for keratinized tissue. Okay. Sorry. So let's go for a case, an inferior case. So it's a regular opening, okay, for like it is for a subperiosteal, you see. And again, the guide, okay, with this is an ancient guide, and also the burrs were the first ones. But you see, we try to go to make a chamfer here on these 2 points. If it is too, if we have a negative crest, we don't even need it to do it, okay? But if we have some type of crest, we need to go deeper, and we need to that the plates go below the muscle insertion, buccinator or milioideo. And you can see the design of the implant. What we want is to force mentalis over here. What we want is to have a negative crest. What we want is that the cheek and the part below the tongue, sorry, I forgot, comes over the implant, okay? And as you can see, there is the preparations. There we don't need it. This is an ancient case, so the connections were different, okay? And from the other side again, and perfect mechanic distribution, okay? And we try to force. We have here, you can see here, start here to see the muscles, the anterior muscles, and also milioideo is here, and we try to put it up here, okay? You can see it. It has to be debrided, and then when we do suture, we pull it up to cover these parts. So this is what you see. This is you will see this a lot of times, fortunately, in the future, but because this is the best way to treat these cases. Just for ending, I still have time, sorry. I just want to tell you that although everyone sees this as a full arch solution, and I know this today, this is a full arch meeting, we can also use it on partial, okay? Although we don't do small partials, okay, we do always the same design, but we can do some cases. In this case, it has only 4 millimeters from the nerve to the crest, okay, and it was really difficult to make put even short implants. So it was decided by the clinician to put here an implant, an individualized implant. So the same principle, okay, putting a guide, okay, this guide will make the bone preparation, and the bone preparation is about 1 millimeter, 1 millimeter 0.5, not much more than that. And you can see here that we came to the oblique line from one side, the internal and the external, to hide our plate, okay, to put, it's nothing that it's that new. If you go see what Dr. Linko has described. He already described this in the past. In reality, I have to say that I didn't invent this, but he says that this was something that could increase a lot and avoid a lot the exposure. And then you can see it here. And also, in some cases, you can either avoid to do sinus lift, or there is sometimes problems with sinus lift cases, and we can even do it for cases where we have to avoid, for some reason, we don't have bone, just missing two or one teeth, and we can do it without making uh, grafts of the sinus for every reason, whatever. Okay. So you can see it here. So this hole, it was for fixing the guide. Okay. The screws that come here, also an ancient case. The screws, they, as you can see, they have threads to the head. Okay, because these screws, it's very important that they stay here. And as you can see, it's less invasive than placing zygoma implants, because you don't need to see the upper part, because you don't have the risk. First, you don't have the risk to perforate orbita. This is guided. Also, the direction is different. We never go direct. We have about 1 centimeter of safety for the orbita, and it is guided. And also the length of these screws is 22, but it's 22 not because we engage 22 millimeters on the zygoma. In reality, we engage about 8 to 10 millimeters on malar bone. But what we want is that the screws and the cocoon for the screws, the shelf for the screws, the part that the plate that is a little bit bigger for having the threads, come below the cheek. Okay, get out of the arch, zygoma arch. Okay, we need it either for the patient not to feel it. Okay, and also because it's much more anterior and much more easier to place it. So that's why we call it compact. We call it compact because in reality, what we want is the smallest implant as possible. Okay, it's not really the truth for the inferior. The inferior always have to have the design, but due to the bending of the mandible, okay, the flexion of the mandible, and that's why we do these parts here. Okay, so, and this is the healing. You cannot say until you see the until you see the OPG, you cannot say what is below here. It's in reality what you see it's two multi-unit abutments. Okay, and the crowns and the final restoration. Okay, just want to come and tell you that for us, what it's more important, it's to define, it's to have a marriage between mechanics and biology. To have osseointegration, the main thing that we gotta have is not to have micro movements. Okay, like we had on subperiosteal implants, or like we have, for example, in some cases of zygoma. Micro movements below the periosteum will induce bone resorption. Okay, very large bone resorption. For us, also, if you have bone resorption, you will have, on the case of the maxilla, you will have contact with the membrane of the sinus. And if you have micro movement, you have compromised the sealing around the implant. Okay, if you compromise the sealing around the implant, there will be bacteria migrating to the anterior. Okay, and this is the main thing about our concepts, okay, the other concepts, they come from dental, either palatal approach, constriction of the connection that forces circular fibers. All of these, they come from dental implants. But to achieve this, we need to understand that even we are based on plates, it's different to load the plate than to load the bone that it's fixed with plates. Okay, so this is my message.
Thank you. First, I just want to kind of add a comment, and I just want to kind of everyone here who is maybe among the first group in the Washington D.C. area who's firsthand is hearing about this really miraculous solution that can be beneficial for a group of patients that are atrophic, that have no other options, severely atrophic, and we haven't had a very good alternatives. And when I saw this and the work that's going into it, I'm excited about what it can offer to patients who are really at the end of the line. They have no other things that can be done. My question, just to add, and also if there are other questions, is there any time between the placement of the implant and the loading, or is it always immediate loading? What is the time period?
Always immediate loading. The screws that we put, you got much more contact than any other system. If you measure the surface of screws, the surface of face of the bone that faces bone, you will get much more contact than any other system of regular implants.
And a follow-up question before I go to our audience. Have you tried, how many cases have you seen for single replacement, such as like a upper first molar with this?
Well, we have cases. We do some cases of cleft palate, of course, and sometimes it's one or two teeth. We do a lot of cases like this in hospitals, of course, because we do a lot also of face reconstruction. But we do have sometimes we have done already not in the mandible. We never did, but we did sometimes anterior gesmentum, or but we did the first molar upper. Okay, that occurs a lot. People that has tried already to do 2 times sinus lift, or for some reason people has a problem with their membrane. They have a tendency to develop sinusitis, and we just use this solution. Very easy. So we have done about.
How many cases have you had complication, and what were the complications?
Well, to be sincere, let me try to divide it. Okay, complications and timing. Okay, we are doing this since 2016. Okay, the first ones that we did, they were one frame only. They were completely based on subperiosteal implants. Okay, but made it with screws, and also on a fancy way. Okay, but the main problem of these implants were screw losing tightness. Okay, because of this bending. Okay, so we first have 2 arms only going to the zygoma. Then we start to do 2 arms, one that goes near the nasal spine, and another one on the palate. Even so, we always felt, because when you go to the zygomas, it's very there is a very arm tension, you know, and it bends really a lot. So from 2020, we have started to do it in two frames. Okay, and we went for the zygoma screws that are screw locked. Okay, and these are 1,400, I think, and our main problem we have some fractures in the beginning, okay, because the force was not, it was very rigid, okay. Even we start doing FEA, we need to do some let's say we need to some improvements on the analysis, because we pick up the design, but then we polish and we reduce the amount of material, you know. So it was not real. So we have made these small adjustments, okay. And we have from 2 years we don't have any fractures. And the only problem that we felt today, it's we never lose tightness of the screws. It's sometimes it's if you don't notice and somehow you force the screw to the outside, you can feel some edema that will lead to a facial
Dehiscence.
no, to a facial, how do you say, Jesus,
Or like a swelling.
separation, you know. You can have it like an zygoma, okay. You need to have to be very careful. It's something because we do for lots of people. If you gotta have a gap, you better to have a gap on the palatal part than to have a gap on the buccal, because if you don't force it well against, then the direction of the screw will not be inside. And if we have a very 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 thin, because it happens, zygoma, we prefer to have a dehiscence of the tip of the screw to the temporal fossa rather to the exterior, okay. And that these are the main problems.
I've got one more
And
question.
of course, dehiscence also is a problem, but not a problem that needs to be removed.
Have you used this for removable prosthetics for like operators or any anatomically compromised cases?
Sorry, I didn't understand the question.
Any removables using this, such as operators?
Yes, of course, because we do a lot also. We are a craniomaxillofacial company, so we do a lot of obturator prosthesis also, you know. So sometimes we do with we use either locator systems or bars or whatever.
Last question.
So I noticed on the lower, it wraps around the crest, a little bit on the lingual, right?
Yeah.
But on the palatal, I didn't see that.
Yeah, but
Are you
I
scared
tried to
for
show.
that? Yeah, for removable, for example, I think the most distal aspect, a lot of the overdentures tend to fail the distal implants. Is this the case here? You see like the distal aspect maybe getting loose or anything like that because of the force?
Well, let me tell you, we do always let's say we always use prosthesis to make the planning. So although you see it always a little bit inside, and you know that sometimes mandible it comes like this and it does like this, okay. So that's why you saw it a little bit interior, okay. But in reality, it's on the same place. But then we tilt the connections, okay. So we do, let's say, reverse planning, okay? We always use a prosthesis to plan the point where it's going to get out the screw. So we always choose to be between lateral and canine to release the anterior part of orphanation, and between two teeth, because most of the restorations that we do, it's always hybrid restorations, metalloacrylic. So we try not to come out on the center of the teeth, not to have fracture of those teeth.
Rui, thank you so much. I am so grateful to have your time, your thoughts, sharing your experiences with us. I will add that, you know, we're, the FDA approval for Bone Easy is coming to you as soon. I've been in touch with Rui about collaborating and hopefully bringing that and making it available for a number of patients who are really waiting for us. And I think it'll be met with huge enthusiasm.
Okay, thank you.
Thank you, and I look forward to talking with you more and taking this to the next level.
Okay,
Appreciate it.
thank
Very
you.
much.
Okay, bye.
I will see you in Lisbon when you come to Washington DC.
Yeah,
Look forward. Thank you.
sure.
All right.